Hello, Richard here, and welcome to part 2 of this series on how to make your own custom camera mount. Now, in part 1, we talked about what it is we wanted to achieve with our custom camera mount, but we sketched out a few ideas as to how we could design the camera mount, and then we hit Fusion 360, and I walked you right through the process of designing the clamp for the camera mount, the screw for the camera mount, and a knob to go on the screw. And all done in Fusion 360 with a view to then 3D printing the clamp and the knob. And then later on, we're going to machine a screw for it. As I said before, don't worry about machining the screw. If you're not into metalwork, there's ways around that. So in today's video, we're going to be going over the 3D printing. So we're going to pick up where we left off in Fusion 360. I'll show you how you can export your model from Fusion 360 into a slicing program like Cura. And then we'll prepare the 3D printer and we'll transfer the 3D files over to the printer and we'll print off both the knob and the clamp. Okay, so let's get started. Okay, so the next thing we need to do is to get this all sliced up and ready to send over to the 3D printer. Just a quick word about sort of slicing. What we need to do is, with 3D printing, we need to have a model, and we use the CAD program to basically create the model that we're going to be printing. But before we can actually print it, we need to convert that 3D model into a sequence of commands that can be sent to the printer. And what the printer basically does is, imagine when you were back at school and you made those coil pots out of clay and you get a big worm of clay and you coil it round and you build up a pot just from coils. That's all a 3D printer does, but it does it by squishing out really, really thin layers of really hot plastic and basically welding layers of plastic together. It does it in layers. And what the 3D slicer does is it basically takes that 3D model and it slices it into each layer it needs to print and then works out all the coordinates it needs to move the printer to achieve that. So that's the next step. The next step is to basically take this 3D design and then we'll export it to a slicer program, which will then prepare it into files that can be directly 3D printed. That's really easy to do in Fusion 360, so let's have a look at that. What we'll do with our design here is we turn off the analysis because we don't need that for the moment. We'll head over to Utilities, and then we've got a button called Make, and it says 3D Print now, so we'll click on that. And we select what we want to print. So let's select, say, this knob, because we're going to want to 3D print that. And if I click Preview Mesh, it'll whir away for a minute, and then now you can see the mesh it's going to generate. That's actually quite a complicated mesh for that one because there's so much curvature. That doesn't really matter. Now, I've got Fusion 360 already set up to work with Cura Slicer. There are different types of slicers on the market. I use Cura. It's the one I used since the beginning. I stick with that. It works fine for me. I've already set up Fusion 360 to basically send this to Cura when I click the button. So we'll click OK, and that will launch Cura. We'll just wait for that to open. Okay, so here we are in Cura, and it's put the model on the build plate. Right mouse button to rotate that. So we have to now work out how we're going to print this. It's not a case of just like hitting the slice button and off we go. So what we're going to do is consider how this is going to 3D print. Now this one's fairly straightforward. All I want to do with this is click it to select it, and then we'll go to rotate, and I'll click this little red arrow here, and this is basically rotated this onto the build plate. And that's kind of it. That's kind of it prepared. Now, there are a couple of things we want to do with this. One is that, if you remember, I said that when you 3D print things, holes tend to shrink when they're 3D printed. And because the hole in this is quite a tight fit on the shaft, on the screw thread, where we basically cut the screw thread out of this piece to make the inside sort of shape, we don't want it to be too tight. So what I'm going to do, I'm just going to scale this up slightly to make it a slightly looser fit. So I'm going to hit the scale option. Let's have a look. We've got X and Y are about 24 millimeters. I don't want to make it too much bigger. So if I make this dimension, say Y, instead of being basically 24, I make this 25 point, let's say 25.2. And that's scaled it up just a touch, made it just 0.2 mil bigger. And hopefully that'll make it a good fit. Now, if when we print this, and we try and put it on the screw thread and it won't fit, you come back here, scale it up a little bit, print another one and give it a go. So it can be an iterative process sometimes, but that should do for that. The other thing you would need to do is you will need to select your profile. Now for me, I'm going to be printing this with a filament called ASA-X, which is a modified ASA. Now the reason I'm using ASA-X is because it has better temperature handling than PLA. And as much as I love printing in PLA and it's a great filament and all that, the problem with PLA is that once you get it over, say, 45 degrees C, it can warp and distort and it goes soft. And that sort of temperature, 45 degrees C, is quite easy to achieve that in a car. If you left the part in a car on a hot summer's day, if it's PLA, it would warp. Even in the conservatory I have on a hot summer's day, that can reach over 50 degrees in there. And if I happen to leave these parts in there on a summer's day, I don't want them to destruct themselves. So I like using ASA-X. It's slightly more tricky to print with because you need an enclosure and you need higher print temperatures. But for you, if you want to print this in PLA, that's fine. Print with whatever you're happy with. So I'll actually be using ASA-X, which comes from 3dfillerprint.com. Not that I'm affiliated with them in any way. Right, so let's have a look at some of the settings we can make. And this is largely down to your own taste as well. You know, each printer's different. You may have different preferences on what you're going to do. I'm going to set the layer height to 0.2 millimeters because I want this to print quite finely. 0.4 millimeter layer height means the layers will be 0.4 millimeters high. And that's good for quick print jobs. It's a good general thing to print at, but I like printing at 0.2 if I can, because you just get a finer finish on the part. And where this is going to be tactile, I'm going to be, using my fingers on this. I want it to be quite sort of smooth and neat. So I'll go 0.2 on that. So let's just check a few other settings. We've got the wall line count of 4. That might be a bit much. What else? 20% infill densities. Yeah, probably okay. And supports, we don't need to generate supports for this particular design. And build adhesion, I'm just going to do skirts because that just basically will squirt some filament around before it starts, make sure the filament's fully purged through the nozzle. And let me just shrink this up a little bit and we'll click on slice, and this will actually slice the part. It says it's going to take 39 minutes, it's not too bad. And we'll click preview, and then we can just see what it intends to do with the print. So we're just going to sort of scroll through and have a look. And the walls are quite thick, but then 39 minutes isn't too bad a print time. I would consider just using like a wall thickness of 2 because it doesn't really need to be this strong. Although this is going to be a knob that's used on, it's going to take some force. It's not going to be forced all that hard, as it were. And if we look here, this is probably where we do want like a decent wall thickness on this part, because this could be quite weak. And then moving to here, it's printing almost solid on some of these bits. So, I'm going to stick with the full wall thickness on that. I think that'll be fine. Okay, so I think I'm happy with that. We'll see how that prints. So I'm going to click Save to Disk. Okay, we'll give it a file name. I'm going to call this Camera Mount Knob brackets ASA-X and number 1. The reason I name things like this, I would generally give it a name so I know what the file is. I then note down what the filament is, because if I want to reprint this just from the G code, the sort of the printing temperatures and all the other sort of printer parameters are embedded in the G code. So you can't print this G code with PLA, really, wouldn't work. So I tag the filament in there, and then I'll say number 1 because plan A always goes up in flames. So that's that. So I'll save that out, and then we can then move that over to the printer later. And what I'll also do is I'll go File and I'll save the project, and we'll call that Camera Mount Knob number 1, and we'll save the project file. That's handy if we ever want to come back, and if I wanted to reprint this in PLA, I can just pull up the project file and I can tweak the filament or any other settings that I want to make with that. So we'll save that as well. All right, so next we want to 3D print the body, or say 3D print. We want to prepare it for 3D printing. We want to generate the G-code file for that using our slicer software. So again, we'll do make, and we'll select the body this time. Preview it just to have a look. Previewing it doesn't really mean much other than, I guess, a sanity check that you've selected the right part. So we'll do that. We'll send it over to Cura, and then we'll just wait for Cura to load. Okay, so in Cura, now this is coming in the orientation that we want to print it in. If you remember before, we said that because this is a clamp, we want the layer lines to sort of flow around the edges like wood grain almost. We want the grain, you know, if you snap wood across the grain, then it's going to snap really easily. But if you try and snap it against the grain that way, it's much harder to snap. So we want the same sort of structure here. So we want the grain to kind of flow around this direction. So we're going to be printing it vertically up like that. And this should print no problem at all. Now it's warning us here, see these little red areas that's saying that there are overhangs. It should handle that okay. And if it doesn't, well, we'll try plan B. Okay, now this is already set up because of the previous print job we just sliced. This has already got the same settings. So let's just do slice and see what it comes up with. So 3 hours, 31 minutes. That's not horrendous. We'll preview it and we'll just have a look and see what it's going to do with the internals of it. So again, we've got a wall thickness of 4, which, as I say, ordinarily I'd usually print things with a wall thickness of 2. I don't normally go as high as 4 walls, mainly for speed. But this will give it more strength as it is a structural part. So I'm just going to think about that. The infill looks okay. 20% is fairly dense. This is going to be quite strong. Now, what I'm looking at really is the holes around here. If you look at the how it's going to structure these holes, this is an area where you may want to actually modify things like the wall thickness to make the wall thickness of the holes have more layers of filament. So instead of say 4 layers, you might want 8 to make the walls really thick so they resist sort of squishing. But this is okay. 4 is quite good there. Let's look at the other side. This concerns me a little bit more because not so much on the top, because that's almost solid there anyway, where you can see where my mouse is. The concern more is here where we're going to be cutting a thread, because if you imagine here, if I zoom in, with this wall thickness, we're going to be cutting a thread out of here, and it's going to make that a lot weaker. So what I want to do here is actually have it so that this bit prints a lot thicker plastic than the other bit. And we can do that fairly easily using a thing called an infill modifier. So what I'll do is I've previously created some infill modifiers, just things like basic primitive shapes like cubes and cylinders and things like that. Let me just pull one of those in a moment. So that should do it. And we go back to prepare. And I'm just going to move this over here. So we've got this other shape that we've imported, an STL file. It's going to rotate it so that it's in the right orientation for us. And you notice it drops down to the build plate. And that's because we've got a setting that makes that happen. So if I go to settings and if I go to, I never know where this is. Preferences, configure Cura. It's a different place in every program you ever use. And here in the preferences under general, we can untick automatically drop models to the build plate. Normally that's what you want. You do want it to drop things down to the build plate, but with this infill modifier, we want it to hover in midair. So we'll turn that off and then we can actually just hover this up. And what I want to do is just move this piece here so that it just goes through this part here. You just move it along so I can grab the arrow. And I want it to be sort of in there like that so that this protrudes through this entire piece here. And then I want it lined up with the hole. So what I'm going to do, let me just, with this selected, I'm going to go to per model settings, click that. And then I'm going to select modify settings for overlaps and wall line count. I'm going to just set that to something crazy like 8. And you can see this has actually gone translucent now. So if I line it up here, I can actually position it so it coincides exactly with that hole. And I'm going to scale it up a little bit as well. So we'll make it so it's a bit wider, like say that. Just check it hasn't actually gone through the other side, which it probably has. So let's move it back a little bit. We don't want it to go through both bits. And then what we'll do is if we slice again, anywhere that this overlaps the model, it's going to actually do it with, it's going to print with a wall thickness of 8. It gives a much thicker wall thickness. So let's have a look at that. Preview. And then if we come up here and we zoom in on that bit again, oops. Let's have a look, see what it's doing. It's probably not quite thick enough. I need to make this infill modifier bigger. So let's just scale that up again. So do scale, and we'll scale it up so it's about that wide. And what I'm going to do, I'm going to turn off uniform scaling. I'm just going to scale it down the y-axis. It doesn't need to be that long. This is always a bit tricky because I never know which way to move the mouse with this. Because if I move it this way, then it goes back the other way again. So it could be a bug. Fiddly, anyway. So if you Cura guys are watching this, this is non-intuitive how you're meant to drag that. So that'll probably do, rather than me be here all day looking like a sketch out of an Austin Powers film. Let me just rotate this around, and let's go to prepare so I can see what I'm doing a bit better. Okay, that's good. That's coming all the way through there. Let me just oops, let me just double check what I'm doing here. Yeah, that looks okay. That's through that through this piece, but not through this piece. And we'll slice it again and see what we end up with. Preview. And there you go. Now we've got some serious plastic on the go. You can see there that as we get into this hole now, it just prints a huge chunk of plastic around there. And either side of this hole now, we've got solid plastic all the way through. So plenty of meat there to cut a screw thread on. And you can do that anywhere you've got holes, anywhere you've got a hole where you want to be sort of putting force on, or any part you want to reinforce. That's one of the beauties I find with 3D printing, is that you can make parts that have different weaknesses and strengths throughout the whole model. Using infill modifiers, you can really beef up holes or parts that are going to be under load, and you can make other bits lighter and thinner and all that sort of stuff. So yeah, really powerful. Kind of almost impossible to do through traditional engineering techniques. If you try to CNC mill something like that, you can't really mill inside a piece of metal like that. Much harder to do. So 3D printing has got some really good advantages like that. I guess if you're into 3D printing metal, then you get the best of both worlds. You can actually 3D print metal components that have different wall thicknesses throughout and different structures inside. But anyway, I digress. That's looking good. So let's save that to disk, and we'll call that camera mounts. Just camera mount. Okay, ASA-X number 1. I'm going to copy that because I'm going to use that to save the project name as well. So let's save that. And we'll save the project, save project, paste in the name we gave the G code. All right, so that's basically the design finished. We've created the G code for both of the parts we want to 3D print. So the next thing to do is to head over to the 3D printer and start printing some parts. Okay, so the first thing we're going to be printing is the knob, because that's the smallest and easiest thing to print. And we're going to be printing that on my Creality Ender 3 version 1. Now, I must say, this has had a few upgrades over the years. So we've got things like, we've got a Micro Swiss all-metal hot end. I've got a BL Touch bed leveler. There's a Micro Swiss direct drive. At the back, I don't know if you can see, right down here, we've got a Raspberry Pi sort of running the whole thing. There's a few other mods as well, and I'll probably do another video later about all the different sort of modifications. The main thing you notice is I've got it inside a tent. So we've got the fireproof enclosure. And the reason for that is that I'm printing ASA-X as a filament. ASA-X, it's like a modified ABS style filament. So for that, really, you need an enclosure to print it in, as it's really susceptible to changes in temperature. So if I was printing with PLA, I wouldn't need the tent. And as I'm using a tent, if I was printing PLA, I'd have the door open. So with this, we're going to be closing the door and having it fully enclosed. Now on the build plate, I'm using just a sheet of picture frame glass for that. I find that works really well. What we're going to do for that is we're just going to prep that beforehand with a bit of this, the old Elmer's washable school glue stick. And what I'm going to do, I've already got a few layers on there from a previous job. But what I'm going to do is just refresh that a little bit. So we'll just put a bit of school glue over there. And you can see it goes purple when it's wet. I don't know if you can see that on the camera. You might just see a little purple tinge there. And when that goes clear, we know then that it's dried, and we can then carry on printing. And if this was the first time I was priming the glass plates with the glue, I'd put 2 layers on, but because I've already put some on there before, this is just to refresh it a little. Okay, so that's the printer pretty much prepped and ready to go. So what I'll do now, I'll just take you back over to the computer, and I'll show you how I actually upload the models to the 3D printer. Ordinarily, if you've got a standard Ender 3 or pretty much any other printer, you can basically, on the Ender 3, you can just pop an SD card in down here, with your G-code programs on, and you can set everything from the panel here. Because I've got the Raspberry Pi and we're using OctoPi, I'm going to drive everything from the computer. So we'll go over to the computer, we'll upload the files, and we'll kick off the first print job and see how we get on. All right, we're back on the PC, and we're going to have a look at an awesome little program called OctoPrint. Now, I mentioned a minute ago that I run my Ender 3 printer off a Raspberry Pi. So I've got a little Raspberry Pi mini computer, microcomputer, single board computer, who knows. And I basically use that to communicate with my printer. There's a great bit of software called OctoPrint that hooks into that and basically lets you do all the things you need to do with your printer. Instead of having to put in SD cards in your printer and twiddle the sort of knobs on the little display panel, it means you can run everything from a web browser on a desktop, or in fact, you can install the app on a mobile phone and you can control your printer from your mobile as well. I'm using this on a desktop PC at the minute, so let's have a look at OctoPrint. All right, so this is the program, and this initially just gives you like an overview of your printer, so you can see my tool temperature and my bed temperature and a few other things. I'm not going to go into massive depth on this. It's kind of beyond the scope of this video, but we're going to use this to make life a lot easier. Now, ordinarily, you'd put your G-code file, the ones that we created in Cura a little while ago, we'd put those onto an SD card and we'd plug them into the printer. Instead, what we can do here is we can just drag those files straight into OctoPrint, and that will send them to the printer. So let's do that. I'm just going to go and find the files. They're on the other screen. But I'll just drag these G-code files over to here. And this uploads the G-code to the printer. And you can see here we've got camera mounts and we've got camera mounts knob. These are the files we sliced earlier. So what I'm going to do, I'm just going to select the knob to print. And you just click the little print icon there, and after a moment or two, it'll start to do its thing. So you'll see here that on the bed temperature set point is set that to 85 degrees, and the bed will start to warm up. So you can see the bed temperature here starting to warm up. And then when that gets at the temperature, it'll warm up the tool and the print job will start. Over on the left, it's really convenient. You've got like a print time left indicator, which is fairly accurate as well. That works pretty well. So this says it's going to be a 40-minute print job. Along with a whole load of other stuff. One of the other cool features of this as well is if you click control, you can actually see a webcam. So we've got a webcam in the printer as well. It's actually, on this one, it's the Raspberry Pi cam. So it's the camera that goes with the Raspberry Pi. That's set up on a little bracket, just monitoring the print job. So we should be able to get you some footage of this job as it prints as well. There's a few other cool things on here. I won't go through all of those because, as I say, they're a bit beyond the scope of this tutorial. If you want any more info on OctoPi or OctoPrint, then let me know in the comments and I can do another video on that, no problem. Okay, so let's see how our temperature's doing. So we're up to 50 degrees on the bed. This is going to take some time to do. So what we'll do is we'll let the print job run and then we'll come back afterwards and we'll see what we've got. Okay, so that's the knob finished printing. So let's see if we can get that off the print bed. Let's get rid of the skirt and the little pre-print piece, and let's have a look. Nice, that's on there. Okay, so let's take a little look at what we've got here, and hopefully the camera can focus in on that for you. You can sort of see what we've printed there. It's all looking pretty tidy to me. So you can see we've got the little sort of notched shaft keyway kind of thing on the inside. Yeah, that's that done. Okay, so next we'll kick off printing of the clamp and we'll see how that turns out. Now that's finished printing, so let's see if we can take off the build plate there. That came off nice and easily. Maybe a bit too easy, but it did stick on there. So let's see what we've got. You can see here on this back edge, if I get that sort of lined up for you, you can see that it hasn't quite printed that. You know, we said about the printer being able to print sort of radiuses, radii straight up. This side's gone fairly well. There's a little bit of undercutting there. But this side, it's sort of struggled a bit, but it doesn't matter for what we're doing. That doesn't matter at all. So maybe could have done a slightly tighter radius on that, but that's okay. It's not going to affect anything. But the rest of it looks pretty good. All looks fairly tidy. You can sort of see the idea of the clamp there and how that's going to close up on the bar of the boom stand when it's all done. Hopefully you'll be joining me in the next part, which will be part 3. And in part 3, we're going to be machining a screw for this, and we'll be putting it all together and finishing it off. Well, as always, I hope you found this video useful. And until next time, thanks for watching.